Let's go back to physics once again regarding forces. So we need to discuss first. Our focus for today is to discuss only the normal force, weight force, tension force, but not on the horizontal, movement or motion. It's vertical na talaga siya. Okay? Ito point. So, but before that, we need to recall the overview of contact forces. Okay? So it's gonna be like contact forces example. We have applied force. Okay. Review or recap. Applied force. We have frictional force. Okay. Frictional force meaning the static force, huh? Don't be confused. Okay. Static force. Sometimes it's called frictional static force to make it complete. That understood to me. If you say frictional force, it's okay also. If you say static force, it's also okay. If you say frictional static force, better. Okay, number 3, we have the normal force. Okay. Okay. Number 4, we have the weight force. Okay. All of us have weight force directed downward. All people of the world. Our force weight is directed to the Earth's ground surface. Okay, because of the gravity, something like that. Okay, and air resistance. Okay, because without this weight force, then we will be thrown away into the solar system. This number 4. There's magic in number 4 that God gave to us. Okay? See, it's natural. Okay? Then we have non-contact forces. Okay, mga palangga kong hitad. We have, okay, number 1, the weak nuclear force. Okay. I love this nuclear force really, okay? And then strong nuclear force. Okay. So strong nuclear force is also interesting, but the weak nuclear force are more, enjoyable. Okay. Number 3, we have the gravitational force. Okay. And then we have also the electromagnetic force. See how many topics you'll be able to touch in terms of forces. Electromagnetic force. And this will be subdivided into electric force and magnetic force. So there's a lot, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9. So the other forces will not be considered is more on chemistry. Katong mga Wick van der Waals forces, intermolecular forces, like that. Okay, London dispersion forces, dipole forces. So it's more on chemistry, but here is more on physics, right? Okay, and we have also the Debye forces, the Cosine forces. There's a lot of forces actually in chemistry. Okay, may mga palangga? Oh, ganon. Okay, so we are here in the normal force, this one. And weight force, and then we have the tension force. It's not mentioned, right? So tension force also. Okay, number 6, tension force. Okay, and then for the non-contact forces also we have the centripetal force. Sorry, I forgot. Okay, so how many? For example, if the teacher and the instructor will say, enumerate the different kinds of non-contact forces, and there's no numbering, she will put as more answers you have. So 7, 1, 2, 3, 4, 5, 6, 7. Okay, and then enumerate at least 5 contact forces. You answer only this one also. Enumeration, but in the examination in the future, there's no such like that. Computerized examination is only multiple choice. Okay? You get the points? You don't have to worry. Only for classroom instruction examination, prelim, midterm, and finals, something like that. But in the future, it's gonna be 150 questions. All are multiple choices. But you cannot also answer if you don't solve like that, if you don't think. Okay, now our main topic is normal force. What is a normal force? Okay, normal force, weight force, and we're gonna be touching also tension force. Okay, like that. Okay. Normal force is the opposite force of the weight force, or opposing force of the weight force. Weight force is directed downward and normal force is pointing upward. So they are opposite with each other. Okay? So meaning to say, if you try to consider the horizontal, this must be considered as your fractional force. Okay? You get the point? So weight force directed downward is a force directed downward. Okay? Normally it's mass. Okay. Tension, mass and acceleration due to gravity. Okay, because vertical. Okay. Tension force is the force, okay, involved directing away from the central of gravity or from the point of consideration in your object or in your motion. Okay? So meaning to say away. None. Okay? You get the point. Okay? So, we start now. So that we can understand really how to compute, we need to understand the FBD. FBD, free body diagram of all your forces. Okay? I think this is physics, right? In high school. I think so. Charot. Okay, case 1. Charot. Okay? So, before anything else, we need to know the definition of a net force. We know that already, right? It's the summation of all forces involved, whether it is in horizontal motion and in vertical motion. So like that's the summation of all the forces F net. Okay, like that F net is equals to, for example, downward, upward, like that. So forces upward, okay, plus forces downward. Okay, this is X horizontal. And then F, summation of F net vertical. This is why palaka, because arrows down, arrow up. And then X will be also arrow left plus arrow plus. Okay, I make this way, it's that easy to understand. So arrow up will be all the forces going up, and arrow down will be all the forces going down. And in the horizontal axis, all forces going to the right, okay, and all forces going to the left, and you need to add that. Okay, the only difference here is that in the horizontal axis, usually it's moving. Okay, moving. Meaning to say you could not expect all the time that your F net will be equal to 0. It's always greater than 0. Okay, especially if you have the applied force and retention force. Unless you have a very, very big value of your fractional force, the opposing force of your retention force, and your applied force, right? Okay? Ganun ba yun? Ganon. Okay, nakakaloka. Okay? Then, sa vertical, guys, the difference is your F net will always be equal to 0 because it's not moving on the horizontal. It's steady. Okay, steady, only moving up, moving down, moving up, moving down. So your F net will be equal to 0. Unless you will push that also too much to the right, in the equal position, whatever. Usually 0 talaga siya, guys. That's the difference between forces vertical, net force vertical, and net force horizontal. Horizontal is this, okay, 0. Oh no, vertical 0. Okay, and horizontal is always like that. Okay? Get the point? So 0 per and vertical. Not always the case, but kasagaran siya, guys. Okay? You should understand the problem. Okay? Ganon. So, ariyo ka sa mga FBD situation. O, diba? Okay. For example, matalangga akong hital. Okay? First case, so it's gonna be like the box is resting, right? Okay. And then the second version will be number 2. The box is like this. Okay. This is the box. Okay. Put in the inclined position. Ganon. Okay. So, ganon. How can we establish the free body diagram? Okay. Ganon. So, weight going downward, W, right? And then upward force is the normal force. Gan chuba chuchu. Okay, so there's no other forces involved? Yes, there's no other. Okay, like that. So your summation of your forces, net force Y or Fy is equals to the, positive Fn going to the up. Oh, positive. And then minus W going to the down. Oh. Doon na kay summation of your vertical forces Fy. Or summation of your vertical forces net. It's just the same. Okay? You get the point? It's up to you if you put net y or nothing. It means the same, right? Okay? Summation Fy or net, Fy na lang for sure, is equal to normal force, like that. And then this is gonna be weight is mass times acceleration due to gravity. As I told you earlier, since this is not moving, so your summation of your vertical force or net force is equal to 0. So we can say in this case that normal force is just equal to your weight, and the normal force is equal to the mass times acceleration to the gravity, like this. Okay. Some problems in physics also very easy to calculate this now. Calculate the force of Zotero standing on the ground. Di mo kagamay. Calculate the force of Zotero standing on the ground. There's no given. Okay? There's no given, but you can compute if you know your weight, if you know your mass. So things like that, sometimes you will be amazed because there's no datum, meaning one given. There's no data. Okay? So calculate the force of Zotero standing on the ground. So this is the ground. So I am 65 kilogram. Already I measured that in the morning. This is actual computation now, based on actual. So I am 65 kilogram, my mass. Okay, since I am directed downward, every people of the world are directed downward. There's no excuse. All people of the world, all over the world is directed downward is the gravity. So you need to have acceleration due to gravity. So I will say mass times 9.81. Oh. This is really my weight. Okay? Since the normal force is equal to the weight, so this is also the value of the force. So I have, take mo mga palanggang guitar. I will tell you something. Di ba it's so enjoyable? It's very practical. Okay, so this is 65 kilograms. So I'm gonna enjoying a weight of, okay, so mga palanggang guitar, 65 times 9.81 is equals to, I'll be enjoying force of 637.65 Newton. So this is my weight, at the same time this is also my normal force. So this is the force I'm using every day of my life. If assuming I have a mass of 65 kilogram, I'm not turning fat. Okay, I maintain my weight, I maintain my mass of 65 kilograms, I do jogging every day, and then my force always, also this one, 67.65 Newton. Okay, like that. So it's wrong to say that your weight is 60, in my case, it's wrong to say that my weight is 65 kilogram because that's mass. You get the point? Because if you speak weight, weight is considering the acceleration due to gravity, meaning it's wrong physics grammar. Okay, when you say, what is your weight? And you will say 65 kilogram. It's not the weight, it's the mass. Okay? Because the weight will consider the gravity in the Earth's surface. That's science. Okay? But if you will normally thinking that it's equal, it's up to you. But to be precise, to be correct, that it's not equal, the weight and the mass. Okay? So I have this, 67 Newton. I make this every day of my life. If my mass will not change in my part. Okay? So you can also compute in your own. As long as you have the weighing platform. I have the weighing platform inside my room. So I can compute my force. O, diba? Force na siya kung iingon. Okay? You get the point? Wala siya. Okay, so in this case, you can always say normal force for Jun is equals to the mass of Jun times the gravity of Jun directed downward. Okay. Now, equation is 2, version number 2. Okay? So, the object is in the incline. Okay, ganon. Incline na siya. Okay? Ganon. So, in this case, mga palangga, what you will do for this? Okay? So, we have the free body diagram. upward force is still here also, Fn, and your weight is going downward, right? Dito po mga palangga. Okay. In that case, charot. Okay. In that case, you can create an angle. Okay. So you will say that your angle will be here. So let's say, ipadayo yung mission dari ari. Okay. And then, ganon, maka-create ka of degrees of inclination from here to here. Like, oh, erect diri ari. Nasa ka diri ari. Okay? Erect diri ari. Okay? And then, we have also the Fx, F and X, and F and Y. Okay? And here also, we have the weight Y and the weight X. And then we have also your hypotenuse weight only. Okay? And this is your theta. Here, theta. Ganon. So, you now have your FBD diagram. So, summation of your vertical forces net Fyn is equals to Fn. Okay? You don't have to put angle of Fn because this is always steady. So, Fn. Okay? Minus the angle of the weight here. Okay? Weight. So, sa mo the angle of inclination. So, this is the base. You will say, base ng siya, so you will say mg cosine theta. Okay? Like that. Mg cosine theta. So, nga na mg cosine theta man sa Zotero. Okay? Because this is the formula of weight. mg. Okay? And now we have the cosine theta here man guys. Okay, so you will say cosine theta is equals to, okay, here, the W, okay, the W, Y downward, okay, so this is WX, okay, cosine theta WX, then over W, hypotenuse. And your sine theta will be also equal to, sine theta will be WX, okay, over cosine theta, and your cosine theta WY. Okay, so mo namin mg cosine theta just because of this. You will multiply that one here. Ganon. Okay, see, WY is equals to W cosine theta. Right? WY naman siya. And then yung weight pa mo is mass times G. Ipuno ka mo ang cosine theta. That's why mg cosine theta will be here. Okay, so ito. Summation of the vertical forces is equal to the net force upward minus this downward ang weight mg cosine theta. So this is the equation of your with angle of inclination, and this is your equation without angle of inclination. But both of them are stationary, not moving yet. Okay, stationary. Ito po yung mga palangga, na siya. Again, for stationary without an angle of inclination is just called normal force is equal to the mass and acceleration due to the gravity, and then your vertical forces of the inclined plane, steady also not moving, is equal to the normal force minus the mass and acceleration due to gravity times cosine theta. Okay? Okay, why man siya gawin? Why man siya cosine hindi siya mga panangga kung hitan? Charot! Okay? Yung na siyang tuyukon. Okay, muna na siya. Okay, now if you have, let's say, it depends on the situation. If you have the upward forces, and you have to apply also. For example, this is steady like that. Okay, and you have your weight downward. You have also your net force upward. And sometimes also push this down. So you say F downward, so FD, or like that. You get the point? Okay, and sometimes also, you have also like this, another version. You have the upward net force, and you have the weight downward. And you have also to push this upside. So you have the positive FU, or upward force. Then you do the FBD, and chu. Okay, so here, vertical net forces is equals to FD is down, so F negative FD, negative W, weight down also, plus Fn. One equation here, another story, vertical force equals to downward direction, Fy, upward, sorry, plus normal force upward and weight is always downward. So this equation like that. And take note, the formula of weight is always mg chuba chu. Okay? Weight is equals to mass times acceleration due to gravity. Insert that there so you can solve also. Now the problem is, mga palangga komunidad, if you really push this on the side, okay, how can you do that? If you push this on the side, okay, if you push this on the side, okay, not pushing, but pull, because pushing is not applicable here. If you push this one, then you need to have an angle of inclination. Okay, like that, then it will become zero also. Because cosine, let's say, cosine of zero is, pila may cosine sa zero. Kaya ang angle niya, sa applied force. Okay, I discussed properly. So this is applied force, right? Let's say, mo mo tanan guys ba? You will put everything. Applied force, tension force, normal force, weight force, basta pa dyan giduot ring of force, mataligan force kaya gilibot-libot sa imong black. Okay? So, wala naman ka nga, wala siya angle of inclination, wala naman ka nga cosine theta, di ba? Okay, so wala naman ka siya nga cosine theta. O, klaro na dyan namin ka nga, cosine of zero. O, di ba? So, cosine zero. So, una namin ka nga, cosine zero, 1 lang siya, mahimo na siyang 1. Okay? Una, maura na yung value sa applied force. Okay? Alam nga, magsugod pag na-incline na yun ang block mo na buang, kaya mo siya erase para lang siya incline. So, usually, ang box, huwag yun na siya nag-incline na yun. So, unless the floor is inclined. You get the point? Here, okay, we have a straight, floor man siya na. Ako mo dyan ipugos ang applied force. Okay? So, naman tayo ang iara. So, di na mo i-consider kaya kanan if A, wala mo na siya force directed downwards pag-apply mo sa force initially. So, dili siya mo matter kaya vertical forces na itong i-consider din so mawa ng FA. You get the point? Mawa ng FA, pero ang tension force, mawa din ako siya dapat kintahay, but ang angle of inclination na discutan naman siya mga component na F1, tension Y component, tension X component. Sa katong tension Y mong gamiton. Okay? Naman kay tension force dire let's say, nag-produce siya of 45 degrees. So ang tension Y, imong gamiton na lang niya kay vertical na siya ng tension sa component, gano'n. Okay? Tension Y, tension X, gano'n. Here, di ba ka maka-create kay, di ba siya angle of inclination ang applied force. So, X, wala siya. Okay na siya dali ang mag-create ang angle. But then, if your tension force also will not create an angle, so this na siya ma-appeal. Okay? So, katuloy, kanina siya mga normal cases. Okay? Mabita na i-discuss na ito, wala yung mga horizontal, kaya mura man siyang ma-impractical. Okay? Because if you try to force it. Okay? Pero kung ito yung ang problem sa, problem solving, pwede ragod siya. Ikaw may bahala. Charot! Okay, ganon. Okay. Now, let's go to problem solving. Dali. Nagmamadali. Okay. Okay. Now, I will introduce you a unique example in a Chemical Engineers Board examination in, 1998. Okay. So, sometimes, we collected different kinds of problems based on the past board examination. So it's gonna be like this, masyakan inigal na. Okay, so in June, I'm standing here in the curved mountain chart. So we have 3 curved mountains, June here, like that, ganon. I am in the first curved mountain, ganon. And we have also the second, like this, okay? Ganon. Duhara day guys, oy. Duhara ka curved mountain. Sorry. Okay. Curved mountain. Ganon. Okay. So, for example, ano siya? Okay. So, June went down on the curved mountain at point A. Like this. So, I put the object here at point A. And then, okay, like this. And then, June went to push this back in going to another curved mountain until it reaches to the top. Right? So, of course, there's a velocity. You get the point? Velocity chuba chuchu will be here. Okay? Ganun ang mangyayari. Okay. Now, point B, like this. This is amazing, huh? I think most of the examiners don't get this because this is, this is unique, interrelated with other topics. Okay, like this. So there's a lot of mountain, like chocolate hills, like in Bohol, something like that. So we are here only in the point A, point B, actually point C, point D, point E, point F, and the box is here, the object is here. So I need to push, right? I need to put extra force in order this box to go to the mountain B, which is higher than mountain A, in which I am there standing. Ganon. So if I will create a problem by myself, I will say, the block weighs 5 kilogram at point A. Ganon. At point A. With a speed of, let's say, 15 meter per second going to the point B. Going to the point B. Okay, ganon. So, ganon siya. With a radius, with a radius of 2 meter equally in the two mountain. Pagbuhat na yun, para di ka makasolve. Okay? 2 radius equal mountain. So, equal ang mountain, meaning 2 radius, pareho siya radius. Now, and this one man siya radius, chuba-chucho. What do we mean by radius? So, that is really circular. Okay, so imo niya siya circular in mountain. So, imaginary ka na circle na siya dari. Ganon. And you have the centroid. Ganon. Okay na, mag-FBD na yung ka. So, kanya siya, dito siya common na FBD because it creates a circular, circular curvature. Ganon. So, you will mix the kinematics linear equation to the forces topic in this case. So this is not purely forces na talaga siya. You will link the kinematics linear equation. Now, it will create a circular, something like that. Okay? This is not electrically charged particles, right? And this is not also in the solar system. So we could not attach the, the Albert Einstein, the Johannes Kepler law of equation, and the Newton, right? So we will just go back to the very basic centripetal force. Okay, centripetal force is equals to mv squared over r. Okay? Ano na yun? Diba? Nakakaloka. Mga yung buhaton. Okay, nanamang ka. Okay, now centripetal force 1 is siya. Okay? Okay, mga palangga kung hitad. Ganon. So, here also in the second mountain, there's also a centripetal force. You see Fc2 and this squared over 2r. Then since you are only needing 15 meter per second to push this block going to be, meaning this is your entire speed to push this block. Okay? Then meaning to say this is your constant speed in pushing the object from point A to point B. Ganon. So, the final and the initial velocity is not relevant here. You will just put this as a v or velocity from point A to point B. Hindi siya concern sa mga initial point, velocity. Pero kung yung stricto mo guys, mawa mo sa initial velocity guys, started at rest kasi ang block. So, VO0 to siya. So, it doesn't matter at all. That's why you will say, VF is just equal to V. You get the point? Because it's no longer relevant na siya. Kaya may value ang VO. Na starting sa A. So, the speed is really the V and the VF. The final and the V. Okay, you get the point? Ano na siya guys? Okay. Now, FBD din ka mga palata kung hitad. Alright, kasi permiro, FBD, kayo mo naman hindi. Isaya kayo. So, if you try to push this object there, assuming that they are already rested. Both. Okay? Okay, so FBD, create an FBD for the point A. So, again, normal force upward, weight force downward. Okay, like that. Dito po mga palangga kung hitad, muna siya may tabo. Okay, mali mong buhaton. So, second po, we have, normal force. and the weight. And the velocity is here, traveling there, right? And then we have the radius here, which is, I mentioned, right, 2 meters. So 2 meters here also, and 2 meters here also. Okay, now, you get the point? Now, you need to get the Fy horizontal. Okay, Fy horizontal is equal to the Fn, okay, positive minus weight. Now, take note, guys. At first, it is not yet moving man siya. Okay? You get the point? Okay, nag-stay pa siya dito sa first. Okay. Now, take note, guys, that we have the centripetal force here. Okay, centripetal force. Do we consider the centripetal force? Yes, we need to consider. But in terms of acceleration. Okay, if we have the centripetal force, we have also the acceleration based on centripetal force. Let's say AFC. Meaning it is an acceleration obtained by having a corresponding centripetal force. Okay. Now, again, this is also second law of Isaac Newton, the law of acceleration. So, you should, malalim kasi ang pinaghugutan dito. Okay, you need to connect the kinematics linear equation to second law of Isaac Newton and to the law also of the forces, the contact forces. Okay? You get the point? So now, guys, you cannot treat your F net here as 0 because there's a centripetal acceleration that try to move the block. Okay? Unlike the other examples that it always have a 0. Okay, how can you do this? Okay, your acceleration, centripetal acceleration, it's gonna, why consider centripetal acceleration mga palangga? Because that is needed in the second law of Newton. Okay? You get the point? Okay. So, if this is your center, then what is the point of acceleration? It's always directed to the center. So, your AC will be here. AC meaning air conditioning. No, sorry. Or alternating current. No, it's not. AC here is just centripetal acceleration. Okay, we have also AC, air conditioning unit, AC, alternating current. So there's a lot of different meaning. So to make it clear, the AC here is centripetal acceleration. Okay, ganon. So Fy, second law of Newton, we have mass times acceleration. So we have the mass of the object, okay, and then the acceleration, which is the AC, which is upward, so positive AC, right? Ganon. You got the point, mga palangga. Kung hitad, okay, ganon. So, we have Fn, still the same, and we have weight is equals to mass times G. Okay, now this is very, very tempting, huh? Okay, tempting. Why tempting, Sir Zotero? Okay? Why tempting? Okay? So this is tempting because you might try to cancel the mass here on the right side to the left side. No, it's not because it is still subtracted from the net force. You cannot cancel the mass even we are on opposite side. Okay? You get the point, mga palangga kung hitad. Okay. Now, where can you attach this MV squared? Okay, MV squared. Okay? Now, imong tokion. Okay. Now, Fy, this is the force, right? So you will say, centripetal force net also is equals to, okay, mv squared. Okay, mawa na siya ang formula sa centripetal force. Mass times velocity raised to the power 2 over the radius. Ganon. Now, I have here this one, right? mc. So you will equate it also to mc. AC, ganon. So in this situation, mga palangga, kung hitag, makancel ang imong mass. Okay, mass. Ang mabilin, V squared over R. Now, what is your definition of acceleration? That is also V over T, right? V over T. But you are not concerned with time. Get the point? So, never use this. just put that as AC alone. So you will say, for this situation, you will say V squared. Okay, kaya naman taming force, mo na siya, naman kay acceleration, ganun. So mo na imong force. So paunin mo ang imong mass. Charot. Right? Okay, yung maka mass. Mass times acceleration. Paunin mo imong mass in terms of FC. How can you do that? Okay, so paunin mo yung mass. Yung muna sabi ko, FC is equals to, okay, M is equals to over V squared FC times R. Ganon. Okay, so pasok din yung ari. FC, okay, ganon. And then R over V, okay, and then V squared siya, right? And then times pa rin mo siya A, acceleration, ganon. Equals to Fn minus mg squared. Ganon, di ba? Okay. You got the point, mga palangga akong hitad. Okay. Timuha mo na siya yung hitabo. Pinapamahong kay A. Okay. Atong papasok para masabtan guys ha. Okay. Anao na siya guys atong tukion. Okay. Kaya para masabtan. Charot. Okay. For example, this one. Okay. Summation Fy is equals to Fn minus mg, mass times acceleration to gravity. Fy magulit mo guys is mass times acceleration. Right? So, Fn minus mg. Okay. Mass times acceleration. Una nataan na. Yeah. Fy also is also mv squared over r. Sa pa, ma is just equals to mv squared over r. Right? E palibo naman siya. In this case. So, makansel mo ang mass. Okay, ganon. Makansel mo ang mass. Okay, right? Now, you say V squared AR like that. Okay? You get the point mga palangga kong hitad. V squared AR. So, okay, mo na yung libot kasagutan na niya, imo na siya ibalin mo ari. A is equals to V squared over R. Okay? Anak. Okay? Imo mo i-compute ang mass. Okay? Ganon. So, Fc is equals to mv squared over r, then compute the mass. Okay? Muna siya yung ibalhin ari. So, equal na siya. So, makuha na yun mo guys. Okay? You get the point? This is the point A, equation 1. Oh, naman kay speed ito ato. Okay, you get the point? Naman kay speed. Ingon mo siya kay mv squared over r. Okay? Naman kay mass, velocity, nasa kay radius, ipasok sa banga ang mga given. You get the point? Yun naman kay mv squared. Mawar naman gina siya dapat yung kahoy ari. You get the point? Okay? So, we need to say, this mass times acceleration will be equal to mv squared over r. If you try to compute mass times acceleration, we'll be just having equal value answer of mv squared over r. Kaya mawar naman siya force. Okay? So, makuha na naman siya ari. O, ganan. So, like that. So, klaro dyan kayo siya. And for the second point, okay, di man to siya inclined. It's not an incline. But ang imong kuha to guys, ang imong AC ato niya, ano na, mapadong na siya sa ubos. Wala na doon. Ano man to no? Naman rin ang center sa kanong mountain. So, ang imong AC, directed to the center. So, ang imong AC is negative. So, dili na siya yung ani. So, ano na ka? Fn positive, weight positive. You'll say, a summation of Fy is equals to Fn, okay, positive, minus weight, minus the centripetal acceleration AC. Right? Ganon. So, sa amin yung pagkita po na higayon na ron. So, yung ano na kaani, na Fy is equals to Ma. And then Fn, okay, minus mg, ang AC ni mo kay downward. O, diba? O, and then mv squared over r. Then ma plus mv squared over r, and then fn minus mg. Ganon. Solve for fn. Sama rin mo ang fn na nahigayon na. So, it will become positive and minus here. So, you can compute everything. It's easy to compute this because there's mass. Okay? And there's also velocity. Okay? You get the point? So, makuha dyan yung namun dahil siya. I-substitute rin mo mga values. Okay? You get the point mga palangga? Or nalibog mo. Okay? Di na ito ipugos ang mass ng acceleration kasi wala pa tayo value sa acceleration. Ang in v squared over r. Okay? You get the point? Ano siya? Okay? You get the point mga palangga. Okay? Any questions so far? Wala na siya? Okay? Wala na siya yung mga question mo, di ba? Okay. Nga to ra guys. Okay, if you like this video, you can comment down below in the comment section. I don't solve one by one because you know, with very limited space. Okay, then you can solve by your own guys. Okay, following that kind of concept. Okay, so free body diagram, i-add mo, positive, negative, and then apply also the second law of Isaac Newton, ganon, di ba? You can compute na already. Thank you so much for watching this video. You can comment down below in my comment section, and you can click the notification bell for some US updates of I am a senior channel voice. Bye bye, God bless everybody. Nakakaloka.